bucka. Haha. You know the deal.
The next thing we're going to talk about with angles is angles in polygons. And in order to do that, we're going to explore a couple of properties that we talked about in the last two videos. So there's a couple of things going on in this picture here. We have a pair of parallel lines here. So they're straight lines, and we have a transversal here because it's connected to those two parallel lines, and another transversal here, a separate transversal here. So the first thing we're going to talk about here is the fact that we have a straight line here. So as previously discussed, an angle is a fraction of a circle, usually between two lines that meet at a point. But if we have a straight line makes a half a circle, which is 180 degrees. So that entire angle there is 180 degrees. I haven't labeled what the measures of those angles are, so I just called them x, y, and z. But we know that x plus y plus z has to equal 180. So if we look at the fact that we have a transversal here, and thinking about the properties that we talked about in the last video, we know that if we cross the transversal and stay inside the parallel lines, that those two angles there are the same. They have to be the same. So since this one's called x, I can also call this one x, because they're always going to have the same measure. Similarly, over here, we've got another transversal, and if I cross the transversal but stay inside the parallel lines, those two angles are the same. So this angle can also be called z. Well, now if I take those parallel lines away, you can see the shape that we have there is a triangle. And it doesn't matter what size the triangle is. Based on what we just saw with those parallel lines, we know that x plus y plus z has to equal 180. So what this proves is that angles inside of a triangle always have to add up to 180 degrees. So here's an example where we have to use the fact that angles inside of a triangle add up to 180 degrees to solve an unknown angle. Here the unknown angle is x, which is the top angle in this triangle here. And the only pieces of information that we're given is that this angle is 120 and that this one is 130. So oftentimes with these questions, you have to figure out some angles that you're not necessarily asked for in order to get the one that you need, and that's true in this case, really. So what you can start to do is just start to look at this and say, well, what angles can I figure out? And here we know that this angle in total is 180 degrees. So those two angles that make that straight line are supplementary angles, so they have to add up to 180 degrees, which means that this angle has to be 60, because 120 plus 60 is 180. Similarly, over here, those two angles are supplementary, the 130 and the unknown angle there. 130 plus 50 is 180 degrees. Well, now that we know these two angles inside of the triangle, we know that the three of them have to add up to 180. 50 plus 60 is 110. If we subtract 110 from 180, we get 70. And we can just double check by adding 50 plus 60 plus 70, and when we add those three angles together, it equals 180 degrees. So we've solved the unknown angle x there by using the fact that the three angles inside of a triangle always add up to 180 degrees. So what we're going to take a look at next is exploring other polygons. We started with a triangle which just has three sides on it. What I'm going to suggest that you do is you copy down this chart because in the questions at the end of the video I'm going to refer to this chart. For a number of triangles, I'm going to explain what that means in a second, but basically when we have a triangle, we have one triangle, and we know that the sum of the angles in a triangle is 180 degrees from using the properties of parallel lines. Well, the next polygon we're going to look at is one with four sides. So we don't know what the angles inside of a four-sided shape, a quadrilateral, add up to. And we could draw any quadrilateral. You could draw a rectangle or a square. I've just drawn here a quadrilateral. It just has four sides that are all different lengths. So in this chart here, for number of triangles, so what that means is if we choose any vertex on the shape and we try to draw diagonals to other vertices, we try to see how many triangles we can split the shape into by doing that. So we just choose any one vertex to start at, and from that vertex we draw as many lines to other vertices. And I can only do one line here, because if I draw other lines I just go back. I'm just creating the shape again. So I started at this one vertex, and I can really only go to the opposite vertex here. And then I have to stop, and you can see that by doing that we split the shape into two triangles. We know the sum of the three angles inside of this triangle has to be 180 degrees, and we know the sum of the three angles inside of this triangle have to add up to 180 degrees. So when we look at all of the angles that are created there, that's all of the angles in our quadrilateral. And so all of those angles have to add up to, well, 180 times 2, because there are two triangles in here. The sum of all of the angles has to be 2 times 180, or 360. So the next shape that we're going to look at is a five-sided polygon, a pentagon. And once again, to try to figure out how many triangles there are, I'm just going to start at any one vertex. So I'll start at this vertex this time, and try to draw as many diagonals as I can from that vertex to another vertex. And I can only draw two of those lines here. So by drawing those two lines, you can see here now I've created 3 triangles. So that's the number of triangles inside of a five-sided polygon. So once again, to get the sum of all of the angles, since we've got 3 triangles, we know the angles inside of a triangle add up to 180. So we have to multiply 3 times 180, because we have 3 triangles in that pentagon. So once again, definitely make sure you copy down that chart, because I am going to refer to that chart in the questions. So to finish off our lesson on angles and polygons, I'm going to ask you to answer a couple of questions here. So the first one there, we have a diagram where there's a couple of things going on. We do have a couple of parallel lines there. So we've got some transversals. We also have some triangles in that shape. So the question there is to solve x, y, and z on that picture. And the second question asks you to complete the chart that I spoke about in the last little section, where we talked about the number of sides a polygon has and the sum of the angles inside of that polygon. I think I went up to 5 sides. I want you to continue that chart and complete it up to an 8-sided shape, and then create an equation where you can calculate the sum of the angles inside of any polygon, and let n represent the number of sides that the polygon has. If you're able to do that, congratulations, you now have a firm understanding of angles inside of polygons.